Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The heat of combustion of cycloalkanes depends on two factors. 1. The number of CH2 units, more carbons is equal to more energy released per mole, and 2. Ring strain. Higher ring strain adds extra enthalpy to combustion. Moving on to the next step. Cyclopropane, C3H6, cyclobutane, C4H8, cyclopentane, C5H10. More carbons means more bonds to oxidize, so the base heat of combustion increases in the order I to 3. Moving on to the next step. Ring strain also contributes to the heat of combustion because strained molecules have higher internal energy. Cyclopropane has the highest ring strain, 115 kJ/mol. Cyclobutane has significant strain, 110 kJ/mol. And cyclopentane has very low ring strain, 26 kJ/mol. However, this ring strain effect is secondary to the carbon count effect. And for the final step, overall heats of combustion, experimental values per mole. Cyclopropane, 2091 kJ/mol, 3 carbons, high strain. Cyclobutane, 2745 kJ/mol, 4 carbons, moderate strain. Cyclopentane, 30 to 91 kJ/mol, 5 carbons, low strain. So the order is cyclopentane, 3, cyclobutane, 2, cyclopropane, I, 3 to I to 3, incorrect, this reverses the actual order. B, 2I3, incorrect, cyclopentane has the most carbons and highest heat of combustion. D, 3I2, incorrect, cyclobutane, 2, has more carbons than cyclopropane, I, and releases more heat per mole. Therefore, the correct answer is C. Therefore, the correct answer is option C.